Okay, welcome back. We have graphed x squared, right? Now we're going to graph x squared plus 1 and x squared minus 1. Okay, you can see that on these rules. Okay, so let me explain to you the change of rules. The change of rules is that, for x squared, you just have x as input and x squared is the output. X squared is the output. And it produces an output. The output is x squared. That's the rule. Now, wait. Oops, sorry. Okay. For the new rule that we have x squared plus 1. So the output is going to be x squared plus 1. And on the x squared minus 1 is going to be x squared minus 1, x squared minus 1. So we have input. We're going to choose the same input points, and we'll see what output point we produce. Okay, what output points we produce. And with that said and done, right, we know the input and output for x squared. And for x squared, for the input of -2, we have -2 squared and plus 1. So the 4 we got plus 1. So the point become for input of -2, output is 5. And for input of -1, the previous input for x squared is 1, and now plus 1, the output is going to be 2. So all the output from x squared is going to be plus 1. Okay, 4 plus 1 is 5, 1 plus 1 is 2, 0 plus 1 is 1, 1 plus 1 is 2, 4 plus 1 is 5. So that's essentially what we have, and we get these points. And now we're going to put these points in the graph. We're going to put these points on the graph. Okay, so please do it with me. Get your paper, pencil. Okay. And let's see what color I'm going to use. I'm going to use green. All right, so I'm going to use a green. And for -2 now, the output is 5, a point. And for -1, the input -1, the output is going to be plus 1. Now it's 2. And the next one, the next point, 0, the output on x squared is 0. Now for the new output, x squared plus 1 is going to be 1. And for the input of 1, under the rule of x squared, the rule was 1. The output is 1. Now under the new rule, x squared plus 1 is going to be x squared plus 1, so that's going to be 2. And the fifth point is going to be 2, 5. So let's see how the points are positioned. You see all the points are shifted vertically up by 1 unit. All the points, okay, all the points from the same input, they're shifted up by 1 unit. They're shifted up. They're shifted up by 1 unit for the same input, by 1 unit, okay? So let's see what we get when we connect the dots, okay? So now we're gonna connect the dots. And of course, we're gonna use a green. Okay, the color green there. The entire curve is shifted up by 1 unit. So let's see what happens for x squared minus 1. Okay, so here, please work with me. Okay, the input are the same, and the output will be whatever output we had before. And now it's going to be -1. So everything here is going to be -1. So for for example, for -1, the input is going to be -1 squared minus 1, and that is going to be 0. So the next point is -1 comma 0. Now, for 0, it's going to be 0 squared minus 1. It's a -1. Same input 0, the output is 1 less. So 0, the input, output is -1. We continue on this evaluation. So we get 1 squared minus 1. So that's 0. So on this point, we're going to have 1 comma 0. H of 2, and that's going to be 2 squared minus 1, and that's equals to 3. So we get 2, 3. Okay. If we put all of these points along with x squared, and then we'll see what happens. Okay. And let's see what color I'm going to choose. I'm going to use red. Okay. So the red color will be used. So I'm going to get the points, red point. Okay. And these points are -2, comma 3. -1, comma 0. 0, comma -1. 1, comma 0. 2, comma 3. Okay. So under the new rule of x squared minus 1, we got these red dots. Every point is shifted downward. Every point is shifted downward by 1 unit. You see, every point is shifted down by 1 unit. There, shifted down by 1 unit. So that's the effect of subtracting 1 after the square. And you see for the green is go upward by 1 unit, right? So that is very obvious. So in our work, so we can see how the transition takes place and why. Okay, so now let's connect the dots. Connect the dots. Connecting the dots. X squared minus 1. We're going to use red. So for x squared, so let's mark some of these graph to gain familiarity, right? So this is x squared, right? And this is the green. The green is x squared plus 1. And this red here is x squared minus 1. Okay, if we put all of them together, okay, we put all of them together, of course, we're going to consider domain and range in a second. If we put all these three curves together, okay, the black, the green, and the red, let's see if you can mark them. There we go. Okay, so this is the final curve of all three. All three. Okay, so let me make it just a little bit more space. Can you mark these three? Can you mark the 3 curves? Let's do that. Okay. The black That's x squared. Okay. And the red, that's x squared minus 1, shifted down by 1 unit. And the green is x squared minus 1. Okay, now let's look at domain and range. Let's look at domain and range. Okay, so look at domain and range. Okay, the first row will be function or rule, function or rule. Okay, one of the rules, of course, is we still have x squared. And here we have x squared plus 1, and here we have x squared minus 1. Domain, domain are all the same. Range, the domain will still be all real numbers, negative infinity to infinity. That's for all of them, all real numbers. And the range, however, okay, x squared, of course, is going to be greater than equal to 0. That's always true. X squared plus 1, if x squared is greater than equal to 0, then we plus 1. We plus 1 on both sides of this inequality. X squared plus 1 would have been greater than equals to 1. For x squared minus 1, however, it will be greater than equals to negative 1. Okay, so now let's observe some other characteristics of these pictures. So now I'm going to bring all the pictures together, all the graph we have done so far. So we've done this graph. Okay, and we have also done these other pictures. There. Let's see what are the common traits we see among all of these pictures, right? Obviously, they're all symmetrical. They're all symmetrical, right? So let's mark them. The black, which is x squared, right? And that curve is symmetrical with respect to y-axis. The green is 2 times x squared. The blue, okay, the green is 2x squared. And the blue here is half x squared. And the red, of course, is x squared, negative x squared. Okay, all 4 are symmetrical with respect to y-axis. Okay, and the equation for y-axis is, so this line, which is the line of symmetry, we call it, right? This equation is x equals 0. Okay, this line, which is the line of symmetry. Okay, so, and how about this one? These 3 curves, right? We got x squared minus 1 on the green, on the red, sorry, x squared minus 1 here. That's symmetrical with respect to y-axis. And the green is x squared plus 1. All these curves, okay, all parabolas above, all right, what are they? They are x squared, right? 2x squared, half x squared, oops, half x squared, oops, x squared, and x squared plus 1, x squared minus 1. All of these, all the above parabolas are symmetrical. Symmetrical with respect to the line of symmetry, which is y-axis. Y-axis has i.e. x equal to 0. The equation of y-axis is x equals to 0. Okay, so that's one important feature. Under domain of all of the above parabola, all of the above parabolas, they're all from all real numbers, negative infinity to positive infinity. How about range? Range varies. Okay, so we have covered them all. So that's all for now. And next time we're going to talk about horizontal shift, right? So the vertical shift, horizontal shift. So next time we're going to talk about horizontal shift. Thank you.